Thank you very much. Thank you for inviting me and giving me the opportunity to share with you what we can do with simulation digital twins. So I'm Michel Morvan, the co-founder and executive chairman of Cosmo. At Cosmo, what we are doing, we are creating, designing. We have a platform as a service offer. We are a software vendor, and what we are doing is what we call simulation 360-degree simulation digital twin. And hopefully, what I'm going to present is going to partially answer to a couple of questions that has been asked in the previous presentation, but I'm going to focus mainly around uncertainty here. So if I go ahead, yes, if I just look at what happened recently. Unfortunately, we faced this sanitary crisis, and 95% of the Fortune 1000 have seen coronavirus supply chain disruption. So meaning things that were not predicted before, and big disruptions, a huge impact, as you know. And I really like this one. It's it's what about the prediction? If you look at some studies that has been done before about the risks, and it was they were asking people in industry, what is the big risk? And you have here down, it's rare, occasional, frequent, or very frequent, and the impact, negligible, weak, significant, or high. And you can see it was in 2019, and it was sanitary crisis. It's the one in red here, meaning very rare, not big impact. Okay, so that's what people had in mind at the end of 2019. Okay, just keep it. The new thing now is that we understand that uncertainty and complexity are now the new norm. We all experience that. It's very, very clear. If you ask people what will happen in 2020, you're in January. I'm not sure that you would have made the good prediction. So the very important thing is that now everybody know it, and we know that we have to find solutions to manage this uncertainty and this complexity. What do I mean by complexity? Complexity is just the fact that everything is related to everything. So anything happening here can have an impact there, and you have to make decisions in this context. That's reality, and the impact of what happens here to there can be huge, right? So the very important thing that comes from that is predicting the future based on the past alone cannot work anymore. Okay, you look at data from the past. It's useful, of course, you can learn from data from the past, but it's not enough, and it will not be enough. And by the way, it's quite surprising that at the moment we thought in the past that it could be enough. Because if you look at data from the past, and if you use data from the past to predict what is going to happen, you're going to predict things that already happened in the past. But in a complex world, can be any industry, well, a lot of things, and the things that interest you the most are the things that never happened in the past, because that's the thing you don't know, and that's the big question. And the question is, because of that, I really like this. Assume that you're in your car and you see these two directions. Well, you have a problem, and that's what people in industry are facing now, because the CEOs, they're going to their team and they say, for example, let's talk about supply chain. They say, okay, now we have to build a very resilient supply chain. We have to build a very robust supply chain, because we have to be adapted, to uncertainty. And at the same time, they say, oh, but by the way, you have to do that by also reducing cost. And the question is, how can you do that? It's a contradictory injunction. How can I be more robust, more resilient, more efficient, and at the same time reduce costs? And that's a real problem. And why is it a big problem? It's a big problem because you lack visibility. You don't know what is going to happen if you do this, or if you do that, or if you don't do anything. What is going to happen in your system? Is your supply chain, as it is now, going to be resilient? If for any reason there is a virus arriving in a place in the world and making that the demand is going to go down, or your ability to produce there is going to drop, well, if you don't have visibility on what is going to happen, how can you be more efficient? How can you be more resilient? And how can you be more cost effective? So that's the problem. And it's like if you were driving your car, and you're in the night, in the dark, and you don't have lights. Right? So, but the people say, oh, that's no problem. You have great rear view mirrors, and so you can look at what happened in the past on the road. So you just have to learn from that, and you will know what to do, right? Or if you have fog. So the main problem, it's a problem of visibility. How can you know what's going to happen? How can you know what will happen, what may happen, depending on what you do? And that's the big question. And digital twins are a tool, and in particular simulation digital twins, I will say a word about it, are a tool that you can use for trying to have more visibility. Once again, you're not a mentalist, you're not able to predict exactly the future, but it gives you visibility. It's not perfect because it will be based on models, and models are never perfect. I used to say a model is always wrong. It doesn't mean that it's not useful, but it's the case. You gain insight, you gain knowledge of what is going to happen. And the BCG said that the companies which deploy digital twin of their supply chain, for example, have already gained impressive level of control of their complex interconnected system. That's the complexity part. Why is it so hard to know what is going to happen? It's because it's complex. It's because something happening here can have an impact there, 1 month later. And that's what you have to do: identify risks and, of course, make decisions. So I just want to take 1 second to explain what we mean by digital twin, which is not so different than what has been presented before, and what we mean by simulation. There are different ways to mean to understand simulation. When you do VR, you can say, oh, I simulate the world, and this is simulation. When we talk about simulation, we talk, as you probably understand, simulation in time. We give the ability to make the system and to see the evolution of the system in the future. Right? So in a way, it means that you have data from the past. With a digital twin, you can have data from the present to do the replica. But what you're really interested in the industry, in many other sectors, by the way, we are also working with smart cities, but you want the data from the future. And that's what simulation can bring. Once again, it's not perfect, but it's information, it's robust information. So remember when you wanted to travel to France, which is something I highly recommend you to do, because I'm sure you understand from my accent that I'm neither German nor American. You usually wanted to travel to France, and you used a paper map, and you were using this paper map. And by the way, it was okay, it was working okay. And to jump on what was said before, depending on what you wanted to do, you use different maps. If you want to travel with your car, you can use this map. If you're hiking, you're going to use a different one. If you're a geologist, you're going to use another map, right? So you need different maps depending on the purpose. So you were using this map. And then there was kind of a digital twin that is called Google Maps, right? In Google Maps, you have the map and you have the state of the traffic. You know when it's green, it's okay. When it's red, there is traffic jam, and you have this information, right? And that's what I call the data of the present. And you can gather data from the past, but that's a twin, okay? And Google Maps, and then there was Waze. Remember when Waze arrived, they were using artificial intelligence, what I call data-based artificial intelligence. They were learning from data from the past, and they were letting you know what is the best way to go from point A to point B, based not only on the traffic jam now, but what they can learn from data from the past of what will be the traffic jam in 1 hour in different places. That's kind of augmented, it's better than Google. And by the way, that's the reason why people use more Waze than Google Maps. And then there is what could be the future for Waze. I don't know where they are, by the way, today. Two years ago, I talked to them, and this didn't exist. That's why I call it Waze of the future. It's to say, I want to predict what will be the traffic jam on the map in, let's say, 1 hour, 2 hours, not only based on what I learned from data from the past, but from the current situation by simulating how the situation is going to evolve and using really a simulation. That's what we call ways of the future. So it's digital twin plus AI, in a way, data-based AI, not knowledge-based AI. You mentioned the importance of encapsulating knowledge in the twins. That's what we do for doing simulation, right? And this simulation digital twin, it's what you use. It's more or less the same, unless rather than using it for driving your car, you use it for managing your business and doing the industry. That's exactly what simulation digital twins are, right? You have the data from the present, you have the data from the past. You can learn using AI techniques for some parts based on data from the past, but you also have the possibility to describe which part or car or whatever is going to do in the future, and you can simulate that and know what is going to happen. And the good news is that this doesn't really exist for this problem, but this exists for industry. So if you look at what is traditional digital twins, usually, and by the way, I agree with you, this is very, limited definition, but very often when people think of digital twin, they think of a twin of an object, of a physical object, and that's what we call traditional digital twin. So it's a single asset, IoT and sensor driven. It's focused on giving the current state, right? You know the current state, and once again, I'm not saying it's not good. It's fantastic, but the idea is you're happy to know the current state, but very often what you want to know is what is the future state? And usually here it's homogeneous data sources, and when you try to understand the future state, you base it on the past. You learn from the past. While what we call 360-degree simulation digital twin, it's not only one object, it can be a lot of different objects interacting. It can integrate physical, human, financial constraints, a lot of different things in the same twin. Of course, you have what we call a real-time operational simulation, meaning you have the twin, you have the state, but you have the way the twin is going to evolve by itself when it runs. And then you have the possibility at every moment to run a simulation, to know, okay, here's where I am, here's what may happen. And of course, here it's much harder because you need to draw from heterogeneous data sources, but now the technology is here for doing that. And the big thing is that you're going to work with causalities. You're going to take into account cascading effects. And that's why what is hard for the 2 points I mentioned, the first one being complexity. It's complex because you have to take into account causalities, and you have cascading effects, avalanche, things happen there and have an impact here, right? And of course, if you want to take into account uncertainties, you also have to consider causalities. You cannot just look at the past. That's the very important thing. And what I want to say before going into a more specific example of what the kind of things we are doing and you can do for managing this uncertainty, these things today exist, and it makes us our customers, and hopefully more and more people start to look at complexity in a positive way. Meaning, I say, oh, it's very complex. When something happens here, it can have an impact there. So I want to get rid of that. But that's not what we say. We say, hey guys, assume that you know that if you do something simple here, it has a big impact here. And assume that's what you want to obtain, to have an impact here. It's fantastic because now you know what to do to have the impact you want to have. And maybe it can be a very small thing. And then complexity means value. You can be able to use the complexity to find value. And by the way, I'm always very impressed by the value you can go and find, very concrete, when you use digital twin for your system, and what you can see in the system, that because it was too complex to see it before, and now you can see it. So the idea is to twin the system. You have the real world, you create a digital twin, but in the digital twin you put the data, but you also put the rules, the dynamics of each part of the system. You incorporate the knowledge from the brain of the experts in the system. And we have built a lot of different twins that way. And then you can add uncertainties, and you can run simulations, you can do optimization based on simulation, you can run tens of thousands of simulations to find the best way to achieve a specific goal. And once again, it's not perfect, it's not pure prediction, but it gives you visibility. This is something that we are doing, and we have a great partnership with Microsoft, and you know that Microsoft created this Azure Digital Twin, and we are their preferred partner for this kind of twins, the 360-degree digital twins. They are partnering mainly with ANSYS Group for the multi-physics digital twins, and for the heterogeneous twins of a global system, an organization. We have this partnership with them, and their tool allows to track the past, monitor the present, and our part allows to predict the future and take action. So, which is of course very, very important. So I'm going to share with you rapidly now one example. We have been working in different domains, but one, it's with a customer, by the way. Here it's just written a tire manufacturer, but I can say that it's French and it's in the center of France. And by the way, I think there is a logo later on, it's Michelin. And we've been working with them on a very specific problem called strategic sourcing. And so they wanted to by the way, they share this. We had a webinar on the Digital Twin Consortium with them to explain this use case, and the problem is the following: the market, the Chinese market, is a very big market for them, and the question is, okay, they produce 20 million tires every year for this market. There are 1,700 references, different references of tire. By the way, I didn't knew that there were so many different tires, and the question is, okay, where do I produce the tires for these markets? I can produce them locally, or I can produce them, from other places in the world. And of course, some references are very, very used, some are more limited. And so the question is, how can I optimize this thing? And it was a big, big, big problem for them. They have been working in the last 10 years to try to find a solution. They didn't succeed. And then they decided to try, this digital twin approach, which is what we did together. So let me just show you how the solution works and some results. At the end of the day, what we decided to show is the customer journey here, just to answer one point. When you create a digital twin, there are different people playing, working with it. Originally, you have to create the twin. That's what we do, or we do with our partners, right? But then, once you have created a general twin, what we call a generic twin for strategic sourcing problem, like you mentioned, it's for a specific kind of problem, then you can apply it to different geographic zones, different companies, and so on and so forth. And at the moment, you don't need to have specialists of digital twin, but you need to have professionals to use the solution. At the end of the day, the digital twin is, it's the back end, and there is people working with it. So the first thing you do is you upload data, meaning you just say, here are my factories. I have this number of factories here in China, this factory is there. I'm going to upload the data. Let's say, giving the cost of customs between different countries, transportation costs, all the costs that will appear at different places, all the constraints, and you put that, and then you have the possibility, once again, here it's very simple, just for the sake of presentation, but you have the different, workflows, and once again, here it's oversimplified. But you have this, and now you have the transportation time, you have a lot of other things here, and it gives you, at a certain level, and that's very important when you create a digital twin, you go at the appropriate level of description. You don't describe everything, you just describe what you need for solving your problem. And now you have that, and you have the dynamics, meaning you have what happens there, what impact it has here, how things are evolving in time, and that's what you put here. And then you can run. You have the possibility. Once you have done that, you can simulate, and you can say, okay, now I have different situation. Let's say I have my twin, and now I say, okay, I'm going to produce this number of tire for each tire. Say this one I produce it here, this number I produce it here. Let's say that's business as usual. You put that, and then you say, okay, what if I would do everything local? Okay, and then you create the scenarios. And once you have the scenarios, you run the simulation. Here it's over 5 years. Once again, you can choose the granularity of the time granularity, and you run that, and it gives you the information about what is going to happen with your current scenario, the business as usual scenario. By the way, it's very important to do that because it's a validation, it's part of the validation process by the experts. They are going to look at that and say, yeah, it makes sense, that may happen. And of course, you can go and look every month what is going to happen, and people are going to look at it, because one of the important things that comes from simulation is that it's transparent. Meaning it's not a black box that says here it's going to happen. You can have a look at what is the sequence of events that happen that makes these results. And it's very important in terms of acceptability, adoption by the people, that they feel confident. And the transparency, the fact that it can go and look at what is happening this month. Oh, there is a problem this month. Where does it come from? Oh, there is not enough tire here, so we have to do that, so it takes time, so there is a delay, so we cannot serve. Right? Oh, that makes sense. And it's very important for adoption. So here you can see that you have, you can look at the income, the total cost, the profits every period of, I think it's 6 months over a period of year or 5 years, and then you can have the total profit. And of course, you can refine, as I said, you can refine the baseline and looking every month how the things are balanced between the storage, transport, production, because you take the storage cost, the transport cost, the custom cost, which is not represented here, and you do all these things, and you have the complete visibility of what is going to happen in the next, let's say, 5 years. And once again, it's not perfect, but it gives you something that you didn't have before. And once you do that, you can say, well, I do that for my original, business as usual. Then I do that for the other one, the local strategy. And then I can say, okay, that's fine. Now I have everything. Why don't I ask the system to find an optimization? What is the best way to organize my production over the years to obtain, what? Best quality of service, more profit, things like that. And that's what you do. You run this simulation and you look at the result. And here, scenario A is business as usual, B is local strategy, and C is what you find with the optimization. And what you find with the optimization, I can tell you, is not at all anything that people had in their mind before. That's what they told us. It's not at all what they expected. And you cannot find it alone because it's too complex. I mean, it's not that at Michelin they're not smart. They're very smart. But it's too complex for any of us, even all of us together. It's too complex for our mind. So here you can have this information that comes from the twin. You run the twin. You simulate the twin. Right? And then you can have this visibility. And here you can say, for example, that for service level, well, the scenario B is very good. But and for stock value, it's good because you don't have a lot of stock. But you can compare with the profit is not as good as with the optimized one. And then you can make your choice, change the parameters. And a very important thing about uncertainty is you could say, oh, scenario B is very good for me. But the problem is that scenario B is very, very sensitive to volatility of demand. Meaning if demand is changing too strongly, well, you have a big problem with scenario B because everything is local and you can have a problem. Maybe demand is going to drop from a while, then you're going to have a lot of stock, and then you're going to, to have a lot of cost. While scenario C, which is the optimized scenario, is very good in terms of robustness. And why is it so? It is very good because when you do simulation, you can put the uncertainty and the volatility of the demand into the scenario, into the simulation, into the optimization, and you can ask and look for a solution that is optimal not only in terms of profit, but that is also very robust, meaning you accept to have a little bit less profit if you gain robustness. So you manage your risk, and why can you manage your risk with this kind of digital twin? Because you can visualize the future and you can test a lot of different futures. So at the end of the day, you can make informed decisions. Once you choose your preferred scenario, you have all the information year by year, all the information, the cost, what comes from the molds, the process, the industrialization, the fact that you have to cost if you decide to do something here, which was done before there, and you don't have you have all the information that comes from this simulation. And the very honestly, I didn't believe the numbers that were here. So by that, they can gain 5% in global profit over the period of 5 years. And more than that, they can save 60% in terms of transportation cost. And by the way, what is not written here, it's also 60% on the custom cost. And it's once again, that's what they're starting to implement now. And to answer your remark before, now we have to wait for a long period to know the real results. But for us, the fact that the people in the field said, yes, now I want to implement this one because I understand why I have more profit, why I will be able to serve the demand, why the level of stock is the good one. Once again, not sure it's going to be perfect, but it's much better than what you can do without this visibility. And it's, once again, it's very, very important. And when I talk with the VP supply chain at Michelin, what he says is the cost of the custom is very, very important, and the volatility on the cost of the custom is very, very important. In particular, for example, if you think between China and the US. So because this can change dramatically, and it's very important to have solutions which are robust to this kind of things. And that's what you can obtain from this simulation digital twin. Once again, it's not perfect, but it can be it can really give visibility, and we have many examples and many twins that exist that already exist in the domain of manufacturing, supply chain, but also energy, where the value that is created is absolutely huge. Just because you gain visibility. Just another example in the domain of energy, we have a digital twin installed really at scale, and in this very case, we have the results and we know the gains for all the French electric high voltage network to optimize maintenance and renewal of equipment. So for France. So 1 million assets, 4 million interactions between assets, all the teams with all the skills of the people where they are located geographically. So, and we can simulate in this very case 40 years. And the RTE is using that and says that they observe 15% of savings. There, we are talking about 800 million spent every year and 15% of savings using this visibility. And the French regulator asked RTE to continue using this and deploy it all over the company because the value created is really huge. So, 2 words about the company. Founded in 2010. By the way, it's a spin-off from academia. I used to be a professor, university professor. I'm not anymore, so you don't have to call me Professor Doctor. It was in my previous life. Now you can just call me Michel. We had 21.8 million funding, 65 employees, 16 nationalities, 14 PhDs. We are a gold partner, Microsoft. We have a very, very strong partnership with Microsoft. We are integrated with Azure Digital Twin, which is a very important point, by the way, because it helps for the integration. To be very transparent, one of the subjects for a company like us, as you can see, we are small. We are touching the core of the business of very, very, very big industries. You know, when you say, I'm going to help you optimize your supply chain, the real one, they're a little bit scared to work with a small company like us because they say, are they going to be able to scale up? Are they going to be able, are they going to disappear or whatever? And when you're backed by, companies like Microsoft and you say, okay, the integration, it will be in Azure Digital Twin. Oh, yes, we have our experts. It's okay. And we are partnering with a very big partners. You have beautiful photos of my co-founder and myself, and we have and we are also a member of Digital Twin Consortium and quite active there because we think that what is happening there is really, really important. Thank you very much. You can meet us also at our booth, but I think there will be a meeting session here, and I would love to discuss, exchange, and be challenged by you. Thank you very much.
Thank you, Michel.